Alright, this is my first stoichiometry video, and in this video I'm going to cover three different types of problems: mole to mass, and mass to mole. So in this example I'm giving you the reactants. Copper 1 nitrate reacts with zinc chloride. So the first thing we have to do is write the formulas for those two, and then predict the products and balance the equation, and then we can get into the stoichiometry problems. So copper with a Roman numeral 1 is telling you that it's copper. That's a +1 charge because copper can be either +1 or +2. Nitrate is NO3. That's a -1. So when you crisscross those, the +1 and the -1 basically go away. You get CuNO3. Zinc is a +2 charge. Chloride is off the periodic table. That's Cl with a -1. So when you crisscross the numbers, you get ZnCl2. So this ends up being a double displacement reaction. The cations and anions are basically switching partners. So this copper that's a +1 will bond to that chloride that's a -1, because remember, you always want the pluses and minuses to go together. So you get CuCl. And now the zinc that's a +2 is going to bond to the nitrate that's a -1. So when you crisscross those oxidation numbers, you get Zn NO3 in parentheses with a 2 outside. Now we have to balance it. I have 2 chlorines on the left, so I need to have 2 on the right. Now that changes the amount of copper, so I put a 2 in front of copper 1 nitrate, and then that also balances out the nitrates. I have 2 nitrates on the left, and I have 2 on the right. So now we can actually get into the first stoichiometry problem. So this says if you have 2.75 moles of zinc chloride, alright, I'm going to write 2.75 moles here. How many moles of copper 1 chloride will be produced? So this is what we're looking for, moles of copper 1 chloride. So you can see that this ends up being a mole-to-mole problem. You start off with moles, you're going to end up with moles. 2.75 moles of zinc chloride. Just like we've always done when we're doing conversions, start off with the number I give you, include the units, and you definitely want to get into the habit of including whatever compound it is. So we want to convert from moles of zinc chloride to moles of copper 1 chloride. And to do that, we're going to need what's referred to as the mole ratio. The mole ratio is basically the ratio of moles of one compound compared to the moles of another compound. And the way you get the mole ratio is by looking at the coefficients in the balanced equation. So you are starting off with moles of zinc chloride. We want moles of zinc chloride to cancel out. That is the stuff that we want to get rid of, and what we're looking for is moles of copper 1 chloride, so that's what goes up top. And remember, whatever we start off with, that's what we always put on the bottom in the next step, the units. Now to figure out the numbers that go in front of the moles in the mole ratio, you just use the coefficients from the balanced equation. It says 2 moles of copper 2 chloride for every 1 mole of zinc chloride. So when you do this reaction, you use up 1 mole of zinc chloride, but you produce 2 moles of copper 1 chloride. And this is why we have to make sure we balance the equations, because we need these coefficients. So now when you do the math, you just do 2.75 times 2, keeping in mind that you're starting off with 3 significant digits, so we want our answer to be 3 significant digits, and you get 5.50 moles of copper 1 chloride. And that ends up being your answer. Alright, so this is a mole ratio. You're going from moles of zinc chloride to moles of copper 1 chloride, and you use the coefficients from the balance equation to figure out what numbers go where. Alright, now we're going to move on to the next problem. Now my reaction ended up getting erased there, just the way this is working. But it's talking about the same reaction. How many moles of copper 1 chloride will be produced from 35.2 grams of zinc chloride? I'm going to write out the reaction real quick, just so we have a nice reference. And it was zinc chloride. Goes 2, I had 2 CuCl and zinc nitrate. And I have it balanced. So now in this one, I'm starting off with 35.2 grams of zinc chloride. and it wants to know how many moles of copper 1 chloride. All right, so I'm looking for moles of that again. But now I'm starting off with grams and looking for moles. So this is going to be a grams to moles problem. This one's going to be a little bit longer. 35.2 grams of zinc chloride. Okay, now what we want to do is convert that to moles. You can't go from grams of one compound directly to moles of another. You have to do this in 2 steps. And really what we have to end up doing is comparing moles to moles. So what I have to do first is convert grams of zinc chloride to moles of zinc chloride. And the reason why I have to do this, remember when you have a mole is just a counting number. It just means 6.02 times 10 to the 23rd particles of whatever it is you're talking about. And what we learned before, for example, if you have 10 grams of carbon and 10 grams of aluminum, you have the same mass, but you don't have the same number of particles, because carbon's molar mass off the periodic table is 12.0, and aluminum's molar mass off the periodic table is 27.0. So you get the same mass, but you get the different number of particles. So what we have to basically do is compare number of particles. But working with atoms or molecules is kind of unrealistic because they're so small, and that's why they came up with a mole to begin with. So a mole is 6.02 times 10 to the 23rd particles. We have to convert these things to moles. Now this is a conversion factor. Do not get it confused with a mole ratio. Conversion factor is what we have been using. It's going from grams to moles of the same compound. So grams of zinc chloride to moles of zinc chloride. Now to get the grams of zinc chloride, you get that from the periodic table. If you find zinc, the molar mass for zinc is 65.4. The molar mass of chlorine is 35.5, but there's 2 of them. So really what you're doing is you're taking that 65.4 and you're adding it to that 35.5 that is getting multiplied by 2. All right. So what you get there is 65.4 plus 71.0. You add that up, and that is your molar mass. So you get 136.4 grams of zinc chloride. Now, to save a little bit of space, I'm going to get this out of here. Alright, so what we have right now, grams of zinc chloride are canceling out. That's what we did the conversion factor for to get the moles. Now what you're left with right now is moles of zinc chloride. So I'm going to write that on the bottom. And we want to get to moles of copper 1 chloride. So now this is going from mole to mole. Moles of one thing to moles of another. That is the mole ratio step. So we used the coefficients from the balanced equation. It's 1 mole of zinc chloride will produce 2 moles of copper 2 chloride. Now in the calculator what you do is 135.2. You basically multiply the stuff on the top, divide by the stuff on the bottom. 35.2 multiplied by 1 doesn't change anything. Then you divide by 136.4, and then you multiply by 2, and you'll end up getting your answer. Now we started off with 3 significant digits, so we want our answer to have 3, which is 0.516 moles. 0.516 moles, and include the units and whatever compound it is. So 0.516 moles of copper 1 chloride is the answer. Now what some people do at first, and if you want to start off doing it this way you can. I'm just going to rewrite a little bit of stuff here. So what some people will do is break this into 2 different problems. So I'm just rewriting this first step. When you get an answer here, converting from grams to moles of zinc chloride, round it off to the right number of decimal places is 0.258 moles. Alright, now what people will do sometimes is get an answer for that and then write out the mole ratio step like we had. I'm running out of room here. And if you wanted to, you could do it this way. It's really just it's just going to take longer for you, and it's going to end up, you're going to have to do more rounding. You'll get the same answer doing it this way because now you're going to be doing 0.258 times 2, which really just gives you that same answer. So what we end up doing usually is kind of putting it all into one problem to eliminate having to write the answer for each step and rounding off each step. This will save you some writing and some rounding, so it's a little quicker. So we usually do it all at once like that. So that was a grams to moles problem. Now for the last one, it's working off of the same equation, so I'm going to write that down again real quick. We have 2CuNO3 plus zinc chloride goes to, I believe it was 2 moles of copper chloride and zinc nitrate. So it is balanced. Alright, now this problem is telling you how many grams of zinc chloride will react with 16 moles of copper 1 nitrate. Alright, so switch it up a little bit. 16.0 moles. And how many grams of zinc chloride will react with it. So now we're starting off with moles and we're going to grams. Always write down what I give you first in the problem, and you're starting to see why I say always write down the units and whatever compound it is that goes with it. If you start leaving that stuff out, you are going to end up having a very hard time figuring out what step comes next. So now you have moles of copper 1 nitrate, so that'll go in the bottom. And what we want to end up doing is going from moles to grams. Moles of copper 1 nitrate to grams of zinc chloride. There's no conversion factor that will let us do this in one step. We can't do it like that. What we have to do is go from moles of copper 1 nitrate to moles of zinc chloride. Now this is the mole ratio step. You get these numbers from the balanced chemical equation. It's 2 moles of copper 1 nitrate to 1 mole of zinc chloride. So moles of copper 1 nitrate cancel out. What we'll have right now is moles of zinc chloride, but I don't want moles, I want grams. So now we want this moles of zinc chloride to cancel out. We want to go from moles of zinc chloride to grams of zinc chloride. Now this is the conversion factor. This is converting moles to grams of the same compound. So it's always 1 mole, and the grams are wherever you get off the periodic table, which is what we just did in the last problem, which is 136.4 grams of zinc chloride. Now you do 16 divided by 2 times 136.4. You're going to get a big number here. It gives you 1,091.2. But this is 3 significant digits, so we have to round this off to 3 significant digits. So the third significant digit is the 9. The next number in line is a 1. Right, so what we end up doing, make this kind of easy here, we could do it 2 different ways. You could do it as 10,090 grams of zinc chloride. Or if you wanted to, you could write it as scientific notation. You could do 1.09 times 10 to the third grams of zinc chloride. Either one of those answers is fine. They are interchangeable at that point. You really only have to show one. But when you're doing this, get into the habit of showing the units and the compound for each step, and in your answer, have the number rounded off to the right number of significant digits, the units, and whatever the compound is. It's kind of a lot of steps, but that's how we have to do it. All right. So pay attention to what you start off with and what you end up with to figure out how you're going to move through the problem. And I think one of the most common mistakes I have, or I see at this point, is in this step right here. Sometimes I have students try and go from moles of copper nitrate to grams of zinc chloride. So they start forgetting things about the mole ratio and messing up the conversion factor. You need 2 steps there.